So, good morning. Today we will discuss about Module 12, Public Key Infrastructure and Encryption. So, in this module, we will discuss about the following topics. What is a public key infrastructure? How the CIA and non-repudiation are implemented. What is digital certificate? How they are used in PKI. Then what are the best practices and risk connected with PKI? These are the goals we'll have to achieve at the end of the day. So start with the first topic. What is PKI? Public Key Infrastructure. It's a framework, okay, which consists of programs, procedures, and security policies, and they employ or implement public key cryptography and digital certificate. So, public key cryptography means we are going to make the communication secure. We have a plain text, the data we want to send. Then we have an algorithm. Then we have a key. Then we make that plain text into secret text called as ciphertext. Okay. And digital certificate, whenever two people are communicating, so the sender may send a digital certificate for the receiver so that the receiver will trust the sender and the data will be not modified during the communication. Anyone who is outside that center. Okay, that's what. So for implementing all these things, we need a framework which contains program, procedures, security policies for cryptography and maintaining digital certificate. That is PKI. Okay. So it identifies users. So every user will be identified. They will be given a particular certificate. Okay. Distribute certificate. Then maintain a reverse certificate. Okay. So sometimes we need to extend the lifetime of certificate. Sometimes we want to revoke, get the certificate back. Maybe he has done some insecure thing. He has done some maybe things which are not supposed to do, like some sort of attacks or something. So we have to revoke, get the certificate back. Distribute encryption keys. Okay, whenever we need to go for encryption, we need keys, no private or public key. That also will be distributed by PKA. For all these things, why we are doing this is for the encrypted communication. Okay. Example for having a banking transaction using website, no. So bankbasket.com, you want to do through website, no browser. We need to have security. For that, we use SSL, secure socket layer. They will have secured communication. Okay, transportless security like that. Okay. Then what are the components of public infrastructure? First one, certificate authority. It's a company which is responsible for issuing digital certificate. Example, VeriSign. Okay. So it is the one who identify the person or server and by using a key, and here is the organization which will issue digital certificate for the particular person. Okay. Then registration authority. So before you request for a certificate from certificate authority, you want to contact registration authority and register your details, and this registration server will do the initial authentication of user. Okay. So if it is not registered and if it is not authenticated, the registration server authority will not forward the request to certificate authority. So first thing, the user should be contact registration server or registration authority. Then they have to be authenticated by the server. Then only the request will be sent back to or forward to certificate authority. Okay. And these users called as subscribers also. Then certification server. So this is a part of certificate authority. So it's actually a hardware and software component which issue digital certificate. Example, in our Microsoft, we have Active Directory certificate services or certificate server. They are the one who issue digital certificate for the user. Okay, it's a part of certificate server. Certificate server is a part of certificate authority also. Okay. Then repository means certificate repository where all your certificate, whenever the user requests certificate, right? This repository is a database where the digital certificates are stored. Whenever user requests for a certificate, if it is authenticated, everything is okay. His certificate will be stored in certificate repository. Okay. Then certificate validation. Here we are checking whether the certificate is valid or not, whether the user can use it or not. Okay. Key recovery service means, so here we know for the encryption we need encryption keys or decryption keys, private or public keys, right? So where you will keep all these keys. Okay. So whenever we lost the key, how do we recover? For all those things we have key recovery service. Okay. Then time server. Whenever you issue a digital certificate, no, there should be a time stamping. So up to what time the certificate is valid, like that. For that we need a time server. Signing server means a server that provides digital signature and verification service. So whenever you are going to send a message to another person, first you have to send a digital signature so that they can verify whether the particular person is valid or not. So who will issue digital certificate? Signing server. It's not like a normal certificate. It's like a digitally, the data will be digitally signed by the private key. Okay, that's what designing server. We'll show examples of practicals and digital signature that I will show you later. Then you can understand. What PKT is not, it's not an answer to all security questions. So we don't think that it will be solving all the security issues. No. It will not stop attack on organizations. It will not prevent downloading malicious codes. It's not a firewall. So PKI is not a firewall. It will not stop the attacks on organizations. There will be security attacks on organization. It cannot prevent downloading of malicious codes. Okay. So it cannot prevent somebody downloading malicious or dangerous codes. It does not provide authorization. They will not tell you what are the things you can do, what are things you cannot do. There is no authorization for PKI. And it doesn't ensure end user can be trusted. So it's not ensuring that the user can be trusted if you're using which one? Certificate or PKI. Thick things about PKI. Okay. So see here, what is encryption, what is decryption, what is cryptography and crypto system. Encryption means the process of applying an algorithm to plain text result in ciphertext. Okay, see here, I'll show you an example. See, I have a data. It's like attack. Okay, so I want to send the message attack to my receiver. We are just like soldiers. Okay, I cannot send the data as it is, so I want to convert it into secret text or ciphertext. So what I will do, I will apply an algorithm with a key. So what algorithm I am applying is add each letter by 3. Okay, so this one 3. So example, okay. So what happened? Attack will become A will be A, B, C, D. Okay, T, U, V, W, W, then D, C. So A plus 3, B, C, D. Okay, so which one? C will be D, E, F. Again K, L, M, N. Like this, I will convert the plain text into secret text so that nobody will understand what is written here. That's what encryption. Converting a plain text like attack into a secret text called a ciphertext by using an algorithm and a key. Here algorithm is adding every number by digit and the key we use is 3. Okay, adding every letter by a number and we use key as a 3 and the operation is plus. What about decryption? So how you get the plain text back to, how do you recover the plain text from ciphertext? Okay. For example, here what I will do, I will use the secret text is the input here. Now I will use -3 to get back ATTACK. This is what decryption. The simple explanation for decryption is read the ciphertext, then decrypt it, and we want to get the plain text. So this is the ciphertext. We use the algorithm -3, then attack is the plain text. Okay. Now, what is crypto system? It's a set of hardware and software and set of algorithms for encryption, decryption. Okay. What are the hardware, software, algorithm used for encryption, decryption? That's called as crypto system. It may be symmetric and asymmetric. Symmetric means use the same key for encryption decryption. Either it is public or private, use the same key. Asymmetric means one key for encryption, say private key for encrypting data, public key for decryption. Okay. So cryptography is actually a science of dealing with secure data. How do we make the communication secure? We convert the data into secret form. We use encryption, decryption, algorithm, everything is cryptography. So what is encryption? I told you. Convert plain text into secret text. Decryption, get the plain text back from ciphertext. What is crypto system? Set of hardware, software, and algorithm for encryption and decryption. Okay, it may be RSA algorithm. For digital signature, we have some other algorithm. Everything is coming under crypto system. Okay. Now, what is digital certificate? As I told you, when individual want to gives or prove his identity to a third party, okay, or a receiver, we need a digital certificate. Okay. So this is a copy of their public encryption key. And who will issue this? Certificate authority will issue digital certificate. How they will issue? First, they have to verify the identity of user. As I told you, there will be a registration server. They have to first get the detail about the user. Then they will authenticate or verify the user. Once the user is authenticated, then the digital certificate will be issued by certificate authority. Okay. Certificate contains the version of certificate, serial number of the certificate, algorithm which used to sign the certificate, name of the certificate issuer, my company, okay, the date of validity, up to what time we can use the certificate, name of the owner of certificate, to whom I created the certificate, his name, public key of the owner. So every user will have public and private key, public key. ID of issuing CA. So who is the one issuing certificate? Okay. So what is the ID of certificate authority? ID of the owner. What about the user ID of the owner who is having the certificate now? Like this. Okay. Now, registration authority, I told you, before you contact the certificate authority for certificate, the registration authority is the main thing. He is the one where the user sent the request. He verify the identity of individual. Okay. He will authenticate whether the user is actual user or not. He will verify the identity, authenticate, and then he will initiate a request to certificate authority for the user. So I have a request. I want to make a certificate. I want to get a digital certificate for my communication. So I will send a request to, say, myself is Rajesh. I will send a request to registration authority and I will give my details, username, my identity, everything I'll give. Okay. Then this registration authority, they will verify whether my ID details are correct or not, whether I am an authorized user or not. Then they will send a request to certificate authority that Mr. Rajesh needed certificate. Okay. And this is for, they will mention the life cycle of certificate also. Okay. How long we need the certificate. So whenever user require a certificate, they request, they make a request to RA and registration authority. Registration authority verify the details. If it is authenticated user or user is perfect user or verified user, then the registration authority will make a request to certificate authority. Okay. This is what happening here. Then registration authority has these components, key generation. They are the one who generate initial keys. Okay. Like private key, public key, they will generate initial keys. Then key distribution. So they are the one who distribute the keys. Okay. Storing the keys. Okay. So all these things are coming under key management. How do you manage the keys? It's coming under registration authority. Okay. So first you want to, it's like a cyclic, okay, life cycle. Start with generating key, then distribute the key, store the key. Once you are being made the key, distribute, then you have to store the key. Okay. Then key usage. When the keys are being used, okay, whenever they need, they can request. Then only they'll issue the key. They will be in storage. Okay. Then key recovery. So whenever the key is being failed, you have to restore the key. Okay. Key termination. So sometimes we have to destruct the keys before they reach the end of life cycle. Okay. We have to terminate the key usage before it expires. Key archival. retaining a key that has been terminated. Okay, whenever sometimes no, the key has been terminated, but we want to return the retain the same key. That for that we have key archival. Okay, key archival. Then some additional things to be discussed while you are managing key. See, key should be long enough to provide protection. So that's why whenever you go for DES algorithm, it has only a 64-bit key. But what about AES, Advanced Encryption Standard? They have 128-bit key. So people prefer that AES algorithm because the key length is more. So there will be more security. Then key should be random and algorithm should use full key space. Okay. So we should use a random key, not like always the same key. Randomly you choose the key and the algorithm should be using the key at its maximum. Lifetime connected to sensitivity of data. Okay, so what about the key's lifetime? How long you can use? If they use the key more number of times, its lifetime should be shorter. Okay. Certificate authority. See here how it is happening. I told you this is the one who issued the certificate. It may be organization, like very sign. Okay. How it happens? See, first a new user, he will give his identity proof. It may be in the form of his ID, identity, maybe you have no what you have, what you see, what you know, like that. Okay. In a type of identity, he will give. Then registration authority will verify the identity. Then send a request to certificate authority. Okay, make a certificate for this guy. Then he will sign. There will be a digital signature and store the certificate in certificate repository. Whenever the user wants to do communication with using certificate, he will fetch the certificate. Okay, or the other party. Okay, the other party, whoever uh, want to communicate to the user, no. So he will fetch the certificate of user and verify the signature. Then the communication is successful. Okay, new user, he want to have a digital certificate for communicate with other person. So he'll give a request to registration authority by giving his identity proof. The registration authority will verify the identity. Authenticated user mean they will send the request to certificate authority that this guy wants a certificate. What the certificate authority will do, they will sign the certificate and store the certificate in certificate repository. Whenever the other party want to verify, they'll fetch the certificate and they'll verify the signature of that certificate. Then they'll communicate. This is what happening in certificate authority. That's what mentioned here. Okay. Then what about in ensuring integrity, confidentiality, authentication, non-repudiation? Confidentiality means it makes sure that only the actual recipient can read the message. No one else can read the message. Okay. If I am sending a message to, I am Rajesh and I am sending a message to Mr. Which one? Hari means only he should read the message. Okay. Integrity. The recipient of message can be certain that message received was the message sent. Okay, if I'm sending a message to Mr. Hari, so Hari should make sure that the message is not modified by anyone. Okay, whenever the message sent from Rajesh to Hari, the message is not modified by anyone. For that, I need integrity. For how do we maintain integrity? We need to have digital signature. Okay, authentication. How we authenticate? How we verify that this is the identity of the particular person? That also is called as authentication. It's also part of your PKI. Non-repudiation, third party verify that message came from the actual sender and not forged by recipient or anyone else. Okay, so non-repudiation means you cannot decline that. Okay, I didn't send the message. Okay, so the receiver will be 100% sure that the message came from the actual sender, not by the third party. This is what non-repudiation. All these things will be verified. All these will be used for the PKI, ensure integrity, confidentiality, authentication, non-repudiation. Okay. Use of digital signature. See, I want to digitally send an email that allow the receiver to verify the contents are not modified after the data was sent. Okay. See, for implementing or ensuring these confidentiality, integrity, authentication, non-repudiation between the email sent from my computer to another person, I need to have digital signature. Okay, I want to digitally sign that email so that other person will believe that this is verified data. The user is verified one, authenticated one, and the data is not altered by anyone. Okay, for that I need digital signature. See how the process happens. The same thing what I written here, there's the diagram. Okay, so this is a sender. She want to send an email to a receiver and he want to verify that and make sure that this is the actual sender sending. The data is not changed by anyone during the transit. All this is I need what? Digital signature. Okay, so sender will send a message. That message will be given to hash algorithm. It's like a secure hash algorithm. This one. What they will do, they will generate a hash or message digest. What is that hash or message digest? It's a random text generated from the actual message. And this is called as hash. This will be given to encryption algorithm like RSA encryption algorithm. There we will use sender's private key and we will encrypt this hash and this will become message digital signature. Okay. So this is what how we generate digital signature and during the process we will send the message plus digital signature to network. Through the network it reaches the receiver side. What the receiver side will do, they will have message.text, right, and digital signature. No, they will generate the another hash. Okay, they will generate a hash from this message using the same hash algorithm. Then we have a digital signature already. Decrypt the digital signature. Use the sender's public key. So here encryption done using sender private key. Decryption done using sender public key. And we will get the hash because the encryption thing, what we encrypted, we encrypted the hash. Okay. When you decrypt the digital signature, you will get the hash. So these two hashes are there. So we'll compare these two hashes. We'll check whether this is valid or not. If the hashes are matching, that means the signature is valid and the user verified, the sender and user receiver verified that data coming from sender and it is not altered. This is what happening in digital signature. Okay. See, creating digital signature, we use hash function. Hash function, this one generate digital message digest or hash value. Then this will be encrypted by using sender's private key to get digital signature. It reaches the receiver. They will separate message and digital signature. Message will be again send a hash algorithm to generate hash. Digital signature will decrypt to get hash. Both hashes are matching means or the communication secured. It is the actual user is sending. Non-repudiation is done. Nobody changed the data. All those things are verified by using digital signature. Okay, this picture is enough. The same thing I read here. Okay. What are the risks associated with PKI? So up to here, what I discuss is what is PKI, public infrastructure, what are the components of PKI, what is encryption, what is decryption, what is cryptography, what is digital certificate, what is digital signature. Okay. Now, what are the risks connected with PKI? Say if PKI management is mishandled, if somebody not managing the public infrastructure, no, the keys will not be secured and the system will fail. Okay. So we need secure communication with multiple keys because we are the one who distribute the keys, right? The PKA. So the key PKA is compromised means the keys will be compromised and everyone will get the keys. Okay. And sometimes physical financial burden will be there. So for maintaining a public infrastructure for a company, we need minimum $1,000 to maximum $2 lakh. So it's too costly for a particular company to keep a PKI in its own. Okay. Why we outsource a certificate authority? Okay. What are the advantages? So why can't we have a certificate authority or certificate server in your own company? Problem is we need to have communication with supplier, customer, business partner, seamless communication. That means whenever we need a digital signature, we need to just all whatever PDF bill or invoice we have, okay, whatever PDF signature we have, which we want to send to the supplier, okay, it's okay. Whatever the signature signed document the supplier said, no, it should be automatically signed with the certificate issued by a certificate authority in cloud. So we need to have a certificate authority in cloud. So you can automatically sign it. If you have the If you want to make your own certificate authority, means we need the hardware, software, everything. We need to download the software. We need to have hardware, everything. But here, if you have a certificate authority in cloud, they will do everything automatically and faster also. And if you have multiple, the company having multiple branches means each branch we needs certificate authority at different location. And it's difficult to manage a certificate authority on every side because the cost of implementing certificate authority, the hardware, software we need, it will be too much costly. Okay, so that's better go for a outsource a certificate authority, or you can just use it from a cloud platform. Then whatever certificate you need, just upload the data, you'll get the signature by using that certificate authority in cloud. Instead of buying a certificate authority, spending huge money for hardware software, it's useless. Okay, because we are not a big company, means go for the outsourcing. What are the best practices for PKI use within a large company and organization? So some questions you want to answer. What are the business drivers for using PKI? So why are you going for implementing PKI? What is the use of that? Okay. What application will be using PKI? So for your company, how many applications are going to use PKI? Is it for email communication or some other financial transactions or all? Okay. What does PKI architecture look like and how will it be used? Okay. What type of PKI architecture you are going to follow? How it should look like? Then what impact it will make on users, customers, business partners. Okay, whenever you make a PKI, public infrastructure, how it is going to impact the users, the customers, or business partners. Where this PKI will reside. Okay, what storage location you are going to keep it for them. So whether you are going to outsource this or you are going to make it yourself in-house. Can the current organization infrastructure support technology? Maybe the company using some other technology and it will be older one. And whether that particular technology will be supporting or infrastructure will be supporting the PKI or not. What database we have to use for PKI? Okay, whether you need to have a separate database for storing the keys and everything, or do we need to have a new database in it or not? Okay. What are the legal and policy considerations for CA? How we are going to handle the legality issues of issuing the certificate. Okay, so whether the certificate is renewable or not. Then what are the trust relationship established? What trust model we are using? All these things. Okay, how will the PKI be deployed when you are going to have a PKI? Issue a certificate. How you are going to deploy it? Okay, how the vendors will be supporting you? How will issue the certificate to the user? Who will have access to system? How you will monitor? Okay, who is going to access your PKI system to distribute the certificate? No, how you're going to monitor if anything happens, like security attacks something. That's what coming under chapter 12. Hope you understood. See you in the next video.